Stacy?
Yeah.
Headed to the airport?
Yes. Oh my god. I'm sorry, what are you?
I'm a neural network. Yeah, I drive cars, I play chess, I do tons of other stuff. Well, not me. Like, others like me. I only do driving.
How do you drive it with that?
Oh, no clue what happens in here. But I am an excellent driver, except this one time. And this other time. Okay, and one time the weather made the lines on the road hard to read. But mostly I'm very good at my job.
Okay, well, I mean, what happened when things went wrong? I mean, what mistakes did you make?
I could not tell you. No idea. Listen, though, I'm very sophisticated. So you just gotta trust me.
So I'm supposed to just take your word for it that you're not going to make the same exact errors now?
All right, let's get you to the airport.
You know what? I think I'm going to walk.
It's 25 miles.
Yeah.
In safety-critical industries where artificial intelligence is required to provide high-impact decision support that can affect life, death, and well-being, trust is crucial.
Where did I put those keys?
In response to the deficiencies of black box technologies, industries have been calling for increased model explainability and interpretability. Human users should be able to understand both an AI's reasoning and its processes. To advance your system capabilities with AI, you'll need more. When evaluating artificial intelligence solutions, industries should always consider an AI's capability to excite. That is, explain, compute, interpret, trace, and edit machine answers. Can your AI do all that? Intelligent Artifacts' Gaius framework can. Gaius is a deterministic, symbolic, and connectionist framework for intelligence. Unlike neural networks that simulate unknown brain mechanisms, Gaius instead emulates well-known cognitive functions, allowing it to process pattern-of-life data symbolically and pattern match on previously learned information the same way a human does. Intelligent Artifacts has been using Gaius agents in production systems since 2009. Solutions can be deployed via the cloud, on-premises, at the edge, or as a hybrid to provide real-time predictions as well as the most relevant and up-to-date information for decision-makers. The company was founded in response to a major gap in an AI industry saturated with narrow, one-off solutions designed for highly specific problem domains. At Intelligent Artifacts, we do not employ neural networks to solve problems. Our innovative Excite-Ready framework is designed to scale across different verticals, while also scaling across the horizontal. Unlike neural networks, Gaius provides transparency in its outcomes as well as its processes, which gives stakeholders justified confidence that mistakes are unlikely and can be definitively remedied. Our trustworthy AI is optimized for deployment to support high-stakes decision-makers in all fields. Let's take a look at excitable processes within Gaius. As previously mentioned, Gaius is a symbolic system that emulates human-like reasoning capabilities. As an example, consider the case of a musical score. Gaius and a neural network walk into a room, figuratively speaking, at the same time, and hear a few notes from someone playing piano. The neural network statistically analyzes the last note heard against a large swath of songs that it has learned to predict just the next note to be played. Gaius, on the other hand, follows an approach more familiar to us. It pattern matches on the sequence of notes heard and predicts at what point in the song it entered the room. From this, it can predict which parts of the song were played before it entered, and which parts the pianist will continue to play after the next note. Additionally, if there are anomalies, such as if the pianist makes errors or changes to the music while playing, Gaius can identify which notes were played as expected, which additional notes were played, as well as which notes it expected to hear that were not played. Gaius can also provide emotional feedback indicating how the song is intended to make you feel, whether it's positive or negative, and decide if further actions should or should not be taken based on that emotional determination. These fields, and others, make up Gaius's prediction object, which can be parsed based on a user's interests. The framework observes incoming data as sequences of symbols. The pattern matching engine matches observed sequences of input data against similar sequences already stored in its knowledge base to provide contextually aware, fully explainable real-time predictions. All processes within, as well as predictions produced by Gaius, are presented in a human-readable format so users can see what is happening and why. For mission and safety-critical applications, it is important to know how long it will take your AI to produce updated and accurate insights in the field. All processes, from observation to pattern match to prediction object, are computable, and predictions, decisions, and actions can be returned in a specified amount of time for real-time operating systems. Each algorithm and each datum within the Gaius framework can be reviewed before and after it is transformed by additional algorithms. Given that the system is deterministic, meaning the same inputs will always produce the same outputs, it is possible to predict specific outcomes based on adjustments in input data or parameters within the system. Traceability should include the path from a specific prediction all the way back to the original records used to train the system that produced that prediction. A proper trace should return an interpretable record or set of records from which a prediction was generated. We do not model input data. Therefore, all training records remain intact and are assigned a unique ID when they are learned. Following the pattern matching process, Gaius provides a prediction ensemble. Each prediction object contains the unique ID of learned records used to produce specific predictions. A user can track these IDs against their application's unique IDs to identify exact training records. What good are explainability, interpretability, and traceability if a user is unable to do something with their findings? If a user spots a problem or something missing from the original data based on a prediction provided, they can drill down into sequences and make any necessary changes to original data. Because we do not model until prediction time, users are able to edit or delete original data sequences without having to retrain the system. In addition to adhering to the Excite model for safety-critical solutions, Gaius offers other benefits that save end users time, manpower, and significantly reduce user cognitive load. Our technology offering is currently licensed for use in healthcare and defense applications in collaboration with our development partners. On top of our framework, we have built the Genie platform for clients to test and build their own custom AI solutions. In 2018, Intelligent Artifacts won the Sikorsky Innovations Challenge for sensor fusion, which has led to continuing work with several Lockheed Martin divisions. We are also pursuing DO-178C to become the first airborne machine learning technology eligible for certification by the FAA to fly on commercial aircraft. You need AI solutions for your systems. We want to help you advance responsibly with excitable solutions from Intelligent Artifacts.
Hey, I was designed for one very specific task, and opening wrappers isn't it.